Hello, I'd like to talk about mechanical analysis of the InjectX for 3D printing. The InjectX design is a hybrid design that offers both the ability to extrude or print and inject while you're extruding or printing and moving. So the components that we're showing here are unique. We have a feed housing, posi melt screw, that is um, fits inside the inner barrel. On the end, on the distal end of that assembly is our plunger head. We have sensors that are pressure and melt sensors. We have a unique patented shutoff nozzle. All this fits inside a pressure vessel. We're showing a roller screw actuator that applies the power to move for injection. Of course, feed housing. We always incorporate a high performance motor and gearbox. And then in this case for the InjectX 3D printing, we have a high performance gib and saddle design. This particular model that we're showing is a 24 millimeter screw with the 44 millimeter plunger diameter. It can produce 74 pounds per hour output, and it can inject 115.8 cubic centimeter of shock capacity. It's a very small, compact, unique, low mass to high output design. Here's some specifications of the unit. You can take a look at what we're offering here, and you can see what the stroke is and the specifics, plasticating capacity, and RPM, linear injection speed, so on and so forth. The unique components of the InjectX for 3D printing include plunger head and plunger technology, which is patented, by the way. We also, which incorporates Belleville spring washers, poppet seat, and the kinetic energy of the Bellevilles create head pressure, which is good for screw recovery, for consistent screw recovery, and it provides closure within milliseconds as soon as the extruder stops turning. We also have precise fits between ID and OD of the pressure vessel and hydraulic seal rings that we show here for unparalleled leakage and shock control. We show the plunger head in open position. Polymer flows through here, pushes the poppet off of its seat, exceeds the force of the Bellevilles. As soon as the polymer flow stops, Bellevilles come back and shut this instantaneously. We have a unique design for our nozzle tips, called our swivel design. It can handle orifices up from 2 to 10 millimeters in diameter, very easily removed by this nut, and the whole assembly comes off. Plug it back in, put a new one on. You can change this out very, very easily and very quickly. Also have larger designs for our very large output printers. We provide unparalleled feedback, both analog and digital feedback to the printer for injection and melt pressures, as well as melt temperatures with our TempSense melt sensors. So features of the InjectX for 3D printing is the ability to inject as well as extrude polymer, which offers precise bead geometry at any linear speed, and it gives you the ability to deploy any nozzle orifice. Number two, we can process all material groups, addressing screw geometry, which we do with the posi screw, metallurgy to match any of the requirements, torque to process full range of outputs, and three, we have the ability to inject different polymers than the primary bead polymer. Number four, we can utilize our patented mini nozzle tip technology, which provides A, necessary head pressure for a consistent output. B, it provides instantaneous shutoff of the extrude aid, eliminating drilling and stringing. C, a quick replacement of the nozzle tip orifice with our cap design. And D, geometry that is oriented at 0 degrees straight or any subset between 0 and 45 degrees. Number five, we analog and digital feedback for position of the injector, injection speed, injection pressure, melt temperature, and melt pressure. Number six, it's quite frankly, it's the industry leading output per unit mass ratio. Number seven, We offer various models to choose from between 15 and 400 pounds per hour. What this gives us is the benefits of versatility and output, which is precise bead geometry at low linear speeds, and that's important. I'll show that in a minute. We move the Inject X around. Number B, the nozzle orifice is not restricted to the extruder side output, which allows for use of small nozzle orifices. Number two, the ejection of the polymer is not oriented. It has the same path as the print bead, which ultimately provides structural strength in transverse directions than the bead/build. That can be very important for higher strength elements that are needed out there in geometries. And number three, the ability to inject different materials into bead build materials, such as a foamed material. So if we look at the design, 3D model of the design, we have our system, which is our gib and the slide system, roller skew actuator. We show the Inject X in a forward position, whereas the plunger head is forced up against the conical seat here, is forced up against the conical seat of our nozzles. Here we can install our sensors, and of course our mini shut nozzle tip technology. So how this would work was we can be printing in a normal mode or speed, and then when we come down to a place where we need very low linear speeds, but we still need to maintain the bead geometry, we have the ability to back up and fill a certain volume of material that then can be injected at any speed or velocity while we're moving at any speed or velocity, axial speed. So here is the ability to inject a large volume of material, as we talked about, into whatever build geometry we're talking about. It could be used to position fixtures or articles or electronic components, for example. The ability that we do not have right now, and we can print at any speeds and maintain a very consistent bead geometry. So what we're talking about is a printer that can virtually move around at any speed while we're building. You can also see what the geometry looks like, how powerful it is, how well constructed, and all the motion and everything is on one axis. So, having said that, if you have any questions about the Inject X for 3D printing, we'd love to talk to you about it. Please take a look here. Give us a call, 330-482-5100. Thank you for your time.